All right, so let's continue lesson 4.1. The independent practice, we're on number 18, and we are on page 83 of the 6th grade Go Math textbook. So Aaron buys a bag of peanuts that weighs 3/4 of a pound. Later that week, the bag is 2/3 full. How much does the bag of peanuts weigh now? Okay, so 2/3 full. Well, when it was completely full, it was 3/4 of a pound. So we know our answer should be less than 3/4. So we want to take 2/3 of 3/4. So rewrite it with the numerators being multiplied together and the denominators being multiplied together. Well, we know 2 is a factor of 4, so 2 divided by 2 is 1. 4 divided by 2 is 2. 3 and 3, we know a common factor of those is 1. So we're left with 1 times 1, 1. 1 times 2, 2. So she has half a pound left. Okay, 19a. Marianne buys 16 bags of potting soil that comes in 5/8 bags. 5/8 pound bags. How many pounds of potting soil does Marianne buy? So she has 16 bags, and they're all 5/8 pound bags. Well, that's just 16, 5/18 times 16. So 5/18, and she has 16 sets of them, and I'll rewrite that as 16 over 1. Okay, well, we know a common factor of 8 and 16 is 8. 8 divided by 8 is 1. 16 divided by 8 is 2. 5 times 2 is 10. 10 over 1. So she bought 10 pounds. All right, number 19. If Marianne's father calls and says he needs 13 pounds of potting soil, how many additional bags should he buy? All right. So if we do this, they come in 5/8 bags, right? All right. Well, if we do 5/8 plus 5/8, that's 10/8, right? That's 1 1/4 pounds. We have another 5/8. That's 15/8, almost 2 pounds. 5, 10, 15, 20, 20/8. Almost, let's add 5 more. 5, 10, 15, 20, 25, 25/8. Okay, what's 25 divided by 8? Okay, well, that would be 3 1/8 pounds, right? So we bought one 5/8 pound bag, another bag, and we got to 25/8 if we buy 5 bags. That's over 3 pounds. She can't buy a portion of a bag, right? So they are going to need 5 more bags. Okay, number 20. 2/5 of the instruments in the marching band are brass. 1/3 are percussion, and the rest are woodwinds. What fraction of the band is woodwinds? Okay, so we have 2/5 plus 1/3 plus the woodwinds, we don't know them, equals the whole band, right? All right, well, let's find a common denominator of 5 and 3. We know that that's 15, right? So 2/5 times 3/3 is 6/15. 1/3 times 5/5 is 5/15. So we could say that the marching band is made up, 11/15 of the band is made up of brass and percussion, and the rest are woodwinds. Well, 15/15 take away 11/15. Okay, this would be the whole band. This is the two that we know. 15/11 is 4/15. So 4/15 of the band is woodwinds. 1/2 of the woodwinds are clarinets. Well, we just need to take 1/2 of 4/15. So 2/15 are clarinets. All right, and C, 1/8 of the brass instruments are tubas. If there are 240 instruments in the band, how many are tubas? Well, that's simply saying 1/8 of the brass instruments. So we have to find out what 1/8 of the brass instruments would be. Okay, so it's 2/5. 2/5 of the instruments in the marching band are brass. So our first goal is we have to find the total number of brass instruments before we can find the number of tubas. Because it says 1/8 of the brass instruments. Well, so how many total brass instruments are there? Well, so that would be 2/5 times 240, which we can rewrite as 240/1. Okay, I know 5 is a factor of 240 because it ends in a 0. So 5 divided by 5 is 1. 5 into 240. Simplifies to 48. And 2 times 48 is 96/1. All right. So we know that there's 96 brass instruments. And of those brass instruments, 1/8 are tubas. All right, so we're going to take 1/8 of 96. We can rewrite 96 as 96/1. I know that 8 times 12 is 96, so I'm going to reduce 96 by dividing by 8 and reduce 8 by dividing by 8. That leaves me 12/1. So there are 12 tubas. All right, 21. Marshall found a recipe for a fruit salad that he wanted to try to make for his birthday party. He decided to triple the recipe. Well, triple means multiply by 3, right? Okay. So, what are the new amounts for the oranges, apples, blueberries, and peaches? Okay, well, that's why they're not like this. we know it's going to be 3 times whatever the amount in the original recipe is because he's tripling it. So apples, he needed 3/5 of an apple. Oranges, needed half of an orange. Blueberries, needed a 1/4 cup. And peaches, he needed 2/3. All right, so 3 times 3 is 9/5. That gets reduced to 1 4/5. I can take 1/5 from 9 with a remainder of 4. 3 times 1/2 is 3/2, which can be rewritten as 1 1/2. Blueberries would be 3/4. 3/4 cup. And peaches, you would need 2 peaches. 1 1/2 oranges, 1 4/5 apple. Okay, B. The amount of rhubarb in the original recipe is 3 1/2 cups. Using what you know of whole numbers and what you know of fractions, explain how you could triple that mixed number. So 3 1/2 cups are needed for the rhubarb, right? So 3 times 3, that would become 9. So we know he needs at least 9 cups of rhubarb. And if you triple one half, you'd get 3/2 or 1 1/2. So 9 plus 1 1/2 equals 10 1/2 cups. Okay, so if you triple 3 from 3 1/2, 3 times 3 is 9. 3 times 1/2 is 3/2. We can rewrite 3/2 as 1 1/2. 9 plus 1 1/2, 10 1/2. All right, last page, page 22. All right, one container holds 1 7/8 quarts of water. And a second container holds 5 3/4 quarts of water. How many more quarts of water does the second container hold than the first? How many more quarts? That's just a subtraction problem. So 5 3/4 minus 1 7/8. Well, I know a common multiple would be 8. So I'm going to multiply 3/4 by 2. And 5 3/4 is the same as 5 6/8 minus 1 7/8. Well, we got to have a problem here. We can't take 7/8 from 6/8. So let's borrow from the 5 holes and trade one of the holes for 8/8. So now we have 4 14/8 minus 1 7/8. Okay, all I did was rewrite one of the holes for the 5 as 8/8. All right, 14/8 take away 7/8 is 7/8. 4 take away 1 is 3. So 3 7/8 more water. (23) Each of 15 students will give a 1 1/2 minute speech in English class. How long will it take to give the speeches? Well, 15 times 1 1/2. So 15 times 1.5, which is the same as 15 over 1 times 3 halves. "45 halves." 45 divided by 2. 22.5 minutes. Okay, 23B. Suppose the teacher begins recording on a digital camera with an hour available. Show that there's enough time to record everyone if she gives a 15-minute introduction at the beginning of class and every student takes a minute to get ready. All right, so we know 60 minutes, right, is an hour, minus 15 minutes. It's going to take 15 minutes for an introduction, plus 15, because every student is going to take a minute to get ready. There's 15 students, plus the 22.5 minutes of actual presentation. All right, so what is that? 60 minus 15 and 15 is 30. 30 and 22 is 52. All right, so there's enough time because it only takes 52.5 minutes. All right, so 23C. How much time is left on the digital camera? Well, that's just 60 minus 52.5. All right, well, 60, that means there's 0 halves in 60 because it's a whole number. All right, well, you can't take 1 from nothing, right? So we're going to regroup. We're going to take one of the wholes from 60 and trade it for 2 halves. So now we have 59 and 2 halves minus 52 and 1 half. So 2 halves take away 1 half is 1 half, and 59 take away 52 is 7. So 7.5 minutes are left. All right, 24. Kate wants to buy a new bicycle from a sporting goods store. The bicycle she wants normally sells for $360. The store has a sale in which all bicycles cost 5/6 of the regular price. What is the sale price of the bicycle? All right, what is the sales price? So 5/6 of the regular price. 5/6 times 360 over 1. I know 6 is going to be a factor of 360 because 36 can be divided. 6 is a factor of 36. So 6 times 60 is 360. And 6 divided by 6 is 1. So 5 times 60 is 300. 1 times 1 is 1. So she's going to pay $300. All right, 25. To find the product 3/7 times 4/9, Cameron found the greatest common factor of 3 and 9. He then multiplied the fractions 1/7 and 4/9 to find the product 4/63. What was Cameron's error? Okay, so you see here 1/7. So that means he divided the 3 by 3, which is good. But what about the 9? Shouldn't 4/9 be 4/3 if he's divided by a common factor of 3 and 9? Yeah, it should. So he didn't divide the denominator, 9, by 3. So he simply didn't divide the 9 of 4 ninths by 3, which was the greatest common factor. So his simplified problem should be 1/7 times 4/3. All right, 26. To multiply a whole number by a fraction, you can first write the whole number as a fraction with a denominator of 1. Explain why following this step does not change the product. Okay, so writing a whole number as a fraction with a denominator of 1 is the same as dividing the whole number by 1. It doesn't change its value, right? If I divide any whole number by 1, I just get that number. So the product's got to be the same. So writing a whole number as a fraction with a denominator of 1 is the same as dividing the whole number by 1. And it doesn't change its value. Okay, so the product's the same. I didn't change the value by rewriting it with a denominator of 1. Okay, because if you divided that whole number by the 1, you'd still get the same whole number. So I didn't change the value by putting 1 in the denominator. All right, so that's it for today's lesson. And until our next time, I'll see you soon.